The Purdue University Campus Safety Committee requires a solution to improve campus mobility safety that will prevent people from being involved in mobility-related incidents. The users of the solution will be any pedestrian, bicyclist, or driver that will be traveling across Purdue's campus. This is a significant task because every year, people are injured crossing the street due to vehicle traffic. At Purdue specifically, we observed intersections and found jaywalking to be a prevalent problem that needs to be addressed. As a driver, it can be hard to notice a pedestrian crossing the street, especially during times of low visibility. Our job is to reduce the number of these incidents in a way that is economically sound, aesthetically pleasing, and environmentally efficient. We plan on not affecting the cost of tuition as it should fit within Purdue University's budget. The solution we have created is based upon evidence from testing the solution and gathering feedback from our peers. Our group went through an extensive brainstorming process and after, modeled and tested our top designs until we were left with the best solution. We collected data, used our analytical skills, and plan on introducing our proposal smoothly across campus.
During our design process, we decided to pick our top 3 solutions that we found to be most effective and put a survey out into the pedestrians to find out which they thought would be the best solution for our problem. The stop sign pedestrian crossing display scored the highest with an average of 7.6 out of 10, with the canopy coming in second place with 4.7 out of 10, and finally the pedestrian crossing bridge with 3.2 out of 10.
The final design uses an RGB light and a pole that is activated by an ultrasonic sensor at the bottom here. If the distance reading on the sensor drops below a certain amount, in this case 10 centimeters, then the code in the microcontroller here will activate the lights and leave them on red for a predetermined amount of time based on the size of the intersection. If during that time another person crosses through the sensor path, the timer will restart and the light will stay red for longer. Once that timer is up, the light will switch back to yellow, signaling the drivers to be on the lookout rather than to stop. This entire unit will be placed at the end of sidewalks in minor intersections. Here we have the financial analysis for our solution. The table shows a breakdown of each component of the proposed solution. As you can see, the structure of the pole will be aluminum. It also shows all the other components and their individual prices. The estimated overall cost of the entire solution will be $1,107.63. This is well under the budget of $2,000 per unit that we set ourselves. The actual design of the unit will be a metal pole with 4 holes on each side. Seeing as how it is a circle and there are no sides, the holes are at a 90-degree offset to each other. The actual pole is 54 inches tall and the rest of the dimensions are shown in the diagram. All distance measurements are in inches.
Here we transition to prototyping. During this stage, sketches, low-fidelity prototypes, and biomimicry were all used to help shape and inspire our designs. From there, prototype decision-making using a weighted decision matrix, WDM, was utilized to narrow the focus on the final prototype. The weighted decision matrix takes factors and constraints such as cost, material, time frame, and environmental impact set by the engineers and client to create a scoring system for prototypes. The highest weighted scoring prototype becomes the final prototype and moves on to further refinement for production. In our case, we narrowed the prototype field to 3 and then narrowed again to our final solution using the weighted decision matrix. Our final solution is the pedestrian indicator, pictured here. The pedestrian indicator's function is to make the driver or drivers more alert of pedestrians at high volume pedestrian and vehicle traffic intersections that do not have dedicated pedestrian foot traffic signals. The indicator is yellow when there is a pedestrian presence on the sidewalk and red when there is a pedestrian presence actively crossing the intersection. The solution is cost-effective, self-sustaining, which makes its environmental impact low and is aesthetically pleasing.